Hey everybody, this is Larry. This is day 29 of the Leetcode May Daily Challenge. If it wants to load, hit the like button and subscribe button, join me in Discord. Let me know what you think about today's poem. Yeah, it's loading. Oh, okay. So it seems like we're getting the same problem as yesterday, but the second version. Someone commented on. Well, okay. Let me restart it. I don't want to say it. So I ran today 4 miles. Not that fast. A lot of stop and go. We're just hanging out with people. It was fun. But man, for some reason today just like right now I feel just tired. Maybe I need more sleep. My Knicks are not doing very good. Hopefully tomorrow they'll stay alive for just one more day at least, and then we'll see from there. A comment that I had in my YouTube yesterday on the medium version of this poem is that why do I always reset the poem? You know, like why do am I cheating? Am I preparing for this? The answer is probably not, because if you look at some videos, not all of them, but some videos, you see that I struggle a lot. So I'll be really sad if I prepared and still struggle. Though that said, the internet is not without sad things, so maybe that's a thing. But no. The thing is that at least, especially recently, and more so recently, I think, is that they use problems that I've just solved before. And this one is 3374. And sometimes I'll even say that, oh, it feels like a recent contest problem. And that's just fine by the number. I don't remember anything about it. Just the number, it goes incrementally, right? And yeah, and I know I've solved it. You could even see it here. I solved it. I mean, like I solved it during the contest. If I had to guess, it's about, what is that, like 6 months ago, half a year ago. Those were happier times, but in any case, yeah. So I solved it 6 months ago, and it just during the contest. So if you want to watch that video, you can. I have a video out already on this problem. If you're curious how I solved it during a contest, and yeah, and did we already have ChatGPT cheating by then? Were ChatGPT good enough by then? I don't remember anymore, to be honest. Because I nowadays, another question that I might get is that why don't I do contests live anymore? There are two reasons. Both of them just makes it not fun. The leaderboard is not useful at all. So why, like, no, and I don't get me wrong. I get why Leetcode has a leaderboard and for contests, and also why they clear it. They do a good job of clearing. They try. I get it. I appreciate it. It's an impossible job for like how you can get 100% cheaters. It is just what it is, right? But that said, that doesn't mean that you have a, it doesn't matter. Then don't have a leaderboard, or like don't have a live leaderboard, because it doesn't mean anything anymore, right? Like, like if I want to see how ChatGPT does, I'll just plug in the thing into ChatGPT. I don't need, I don't know, like like at any given time, like half to more than half people above me are on ChatGPT. It's just, I don't know, what's the point? Like, I don't know if I'm doing live, right? And then the other thing is, of course, I complain also a lot, which is that the problems itself is usually okay, but they just don't think about Python and the constraints. So when you use Python in some of these contests, you have to do like one more thing, one more optimization, one more thing to clean it up, which is just, I don't know, like I maybe I'm good, maybe I'm not, but I'm definitely not good enough to do one more thing more than everyone else and still be faster, etc., right? Like at some point, what am I measuring here, right? If I'm not measuring anything to kind of, like at some point, like I'm benchmark not not benchmarking whether I'm getting better. I'm benchmarking whether the problems are getting crappier, right? Like I feel like I'm probably about the same, but then my rating is just a function of how many cheaters get caught and how and the problem's quality. Then it's just like it's not that interesting. Right? That's why I don't do contests. But in any case, this problem, apparently I solved in the before times, so you can check out that video in case you're curious whether I'm cheating or not. And for me, my point is the two things. One is that I also get comments about. Sorry for the long intro, by the way. I get comments about whether like whether I memorize every problem, and the answer is, well, no, because they're like 3,300 problem. Not memorizing all of them, right? I mean, if I'm gonna memorize them, I would just probably I'll probably just prepare instead, right? And then the second thing is, do I prepare for these videos? The answer is also no. That's the point of these videos. If you want if you want like a perfect, quote unquote, perfect, prepared a video of someone solving, then just watch every other video. My point is that this is me live. I mean, when I remember stuff precisely, I'll let you know as much as I can. I mean, sometimes subconsciously, like, like that stuff, who knows how that works, right? But like if I'm like, oh yeah, I did this like last week, of course I know this. And there's some videos like that, right? I have videos where I'm like, oh, I did this problem 2 weeks ago. I am too lazy to explain everything again. Just watch that video. And I will do that because there's no point of me doing a second video, so recently. 6 months, I don't know. And if I don't remember the problem, then it's like solving a new one again. And that's the point of these videos sometimes, right? Anyway, and if you can watch the first time I have this video, and every time I solve a problem, it's on the YouTubes for the most part. I mean, like, maybe there's some times where like I don't even remember this is true, but it may be that I lose a video here and there, just YouTubes and errors and sometimes recording errors, technology. Am I recording right now? I am. Okay, but you get what I mean. There's a lot of stuff that happens, but otherwise they're all on the YouTube, so you can check that out. Like I'm not, I don't know. At this point, you've seen, I have videos of me spending 2 or 3 or 4 hours on a problem, etc. Right? Like, so, I don't know how like, is embarrassment a thing? I don't know, but not for this for me. All right. Sorry, friends, if you're watching the YouTubes. Hopefully this kind of goes through. I know that I recently, a lot of people have came to this channel new, so I just want to kind of explain that my thought process and what this channel is used for. It is, I mean, I will try to explain the problems as best as I can, but a lot of it, I don't want you to just understand the problems. You're not here to understand the problem. This isn't like the SATs where well, I don't even know if that's true, but like, it is not like a multiple choice, you understand. You're not getting paid to understand stuff. You're getting paid to do stuff, for a job, etc. Right? So I want you to do things. I want you to do these problems, and I want you to go when you get stuck. Maybe watch this, pause here and there. Use a little bit hint. I'm here with you most of the days, and I talk about my training journey because these are the things that I'm struggling with, just like you may be struggling with Leetcode, right? So that's why I talk about it, not for any, I'm not trying to be a running influencer or lifting influencer or something like that. So yeah. Okay. Am I finally done with the intro? Hopefully, yes. Let's go. All right. Today we have 3373, and that I need to sneeze. Oh. Maybe I'm allergic to the problem. Okay. Ooh. Talked the entire monologue and it was okay, but as soon as I started doing the problem, I'm sneezing like crazy. Maybe I am allergic to pollen. Alright, today we have 3373, maximize the number of target nodes after connecting trees 2. Okay, so this one, I guess I cheated a little bit, right? In the sense that this is the same problem as yesterday, except for, if I have to guess, n is 10 to the 5th, right? So this is the same problem as yesterday, n is bigger. It's hard to say that I haven't thought about this problem after yesterday's problem. Not even explicit. I didn't even know that they were going to come up. It's just that, like, you see a problem, you go, okay, well, we solved it with n squared. And definitely watch yesterday's video if you haven't, right? But, like, we solved it with n squared. And so you're like, well, what's the natural move, right? And you're just curious if you can do it in linear time. So I did think about this a little bit, but also, honestly, not that much because I was like, I'm tired. I need to get a nap. Like I do now, to be frank. It's my watch telling me to stand up again. But yeah, okay, so let me double check that this is the same problem. So, because I made that mistake before where I assume it's the same problem and it is not, and I'm like, oh, huh. Right, so okay. So let's read this. We have 2 trees, undirected. Are there directed trees? Huh. I don't know. Maybe there is, depending on how you define things. Okay, so you have 2 list of edges, all right, and then you have target. Also, again, another unnecessary term. I actually did rewatch my because of someone commenting yesterday. I did not all of it. I just rewatched the beginning of the first time I did yesterday's farm. So like during the contest, and I think that time I also complained about, and that's as much as I watched, because I was like, I knew how to do this. I don't need to watch this. But yeah, I also complained about all this target phrasing thing. Why create a target thing? Just say within K distance away, right? Like literally has no value other than to confuse people, and not even like it's okay to kind of have a word problem, if you will, where you're adding something to it, and then you get people to kind of reduce the problem to a shortest path from or whatever, right? But here, there's no such thing, right? It's just yeah, it's just like like creating new vocabulary of something that already exists exactly, which is like use the distance with less than or equal to K or something, right? Wait, no. Even? Is this a different problem then? Maybe let me double check. Okay, so maybe I did lie. Okay, let's see. Yesterday it wasn't just even, right? It's less than or equal to K, okay. This time there's no K, there's just even. Okay. So I lied. Alright, I take it back. So I am not quote unquote prepared for this farm. So if I thought I was prepared, I was not anyway. Okay, so that alright, okay. Node U is targeted to we if the number of edges on the path is even. Okay. The one thing to realize about that makes it even worse, honestly, than yesterday's, because if this was the same contest, and probably they are, I'm not going to check it, I'm too lazy, then like, why would you change the definition between Q3 and Q4 or whatever it is, Like you have two problems, you have exactly the same name, and you have almost the same text, and you're changing the definition. Like, in this case, you should use a new name, Instead of target, it's called, I don't know, target 2. Even target 2 is better than target, right? I don't, what are you doing, Leetcode? This is why I'm like, okay. So I am wrong. This is not the same problem. So we'll play around with it. Okay. But n is 10 to the 5th though. So okay, so or n and m if you want to call it that. But excuse me. Okay, so the number of target I'm not going to use the technology. Terminology. Okay, so U and V is relevant if the path number of edges is even, and it's always target to itself or whatever. Okay, I did use the vocabulary. Fine. Return an array answer survives the maximum possible number of nodes that are target to I. Okay. Oh wait, there are random. Oh no, I thought there were queries. That's why I was curious, because I read this of node queries, where maximum number of possible nodes that we connect one node. Okay, I think that's pretty straightforward-ish. Maybe not as easy, but I think the idea is, we'll figure out the implementation, etc. But first of all, the key idea is note that, and of course, the way that I think about these, whenever you think about odd and even lengths or stuff like that, not always, is that I always think about coloring, right? You can think about it as bicolorable. By definition, a tree is bicolorable, by the way, because you can probably prove it to yourself as an exercise at home, but it's bicolorable. So I think about it. In this case, we even makes it more explicit of, okay, there's the two colors, right? And another way to say it, of course, is just that maybe every node could be black and white. And then it just becomes enumeration in a way, right? Let me draw. I'm waiting for my things to load and my I actually have a drawing pad, by the way, at home, so that's why I have to always manage. It's not in front of me because that's where my keyboard is. But okay, yeah. But basically, you have a lot of a random tree, and then you have another tree that looks similar because I'm not creative with drawing. It doesn't have to be a binary tree, right? And then the idea here is that, okay, then now we draw, we color some of we color some of them black. Okay, fine. We'll just draw it in. Okay, so we color some of them black, and it's alternate, right? Bicolorable. So here, I'm lazy, so I'll just do these two instead, right? And then the idea here is that, okay, well, for every node, okay, let's take one tree at a time, right? If we take one tree at a time, for every node, even lengths away is just the nodes that are the same color, right? Pretty straightforward so far. I think we get that, hopefully. If not, then you have to study some tree stuff, because this is just regular things, right? Okay. And then the other thing to notice is that here, then now we don't have to do, we're coloring everything, and we, as we said, so if you're black, you're the same color of all the blacks. If you're white, then you're the same color of all the other whites. So that means that you just count the whites and the blacks, and then you kind of do some counting, bookkeeping, tracking, right? Okay. So then now there are only, for each node, there are only two cases. So maybe four distinct cases together, right? Which is that, okay, what happens if you connect okay, let's actually, I use black and white in both of them, but maybe for fun, let's just use two different colors. So let me color the new tree, right? So maybe we have red and blue. I say it's fun because it is so fun for me to color these in. It's like paint by numbers or something. Okay, right? So then now the question is, okay, well, let's say we're given a black node. I'm putting in a slightly better. Let's say we're giving a black node. Then the question is, do we connect it to a blue node or a red node, right? And that's it. If you connect, and you could walk through this, right? If you're black and you connect it to a blue, and that means that the two distance away, everything will be red, right? And then you just count the number of red ones. And if you, of course, choose this path instead and connect them to the red, then, well, the two distance away will be with the blue, and then just count the number of blue nodes, right? And that's it, you're done. The same idea without laws of generality goes to the right ones, so that's it. That's the entire problem. Color the first graph, or the first tree, color the second tree, count out all the things, and then just pick the max of whichever color will give you the max. So that's the core idea behind this problem, and that's it, I think. Okay. So maybe I can even write a function that just gets it for one tree. So maybe I have a calculate, but, oops, if I could spell that better, that'd be good. Yeah, I mean, I just want to say edges is probably good enough to get the two colors. No, I mean, yeah, okay. We could return the node and the things, right? Okay. Because I'm trying to think through the API of what this means, and that's why, and what to return even, right? Like, do we return, like, one way you can return is the nodes and their color, which I'm going to do because I think we need it that way to answer this query, the answer. The other way was just the number of nodes of each color. So you return two things, like number of black nodes and the number of white nodes. But then you can't differentiate which one is which. So that's why so that's why I was thinking that way. Yeah, that's one way. Yeah, and then now we have color is equal to, say, none times n. And the reason why I like none is that if I still have none, I hope that is intended. I for some stuff like this, I mean, I think it's very common to use sentinels so that you cannot mess up when you're wrong. But sometimes during the programming portion, you want to know when you're wrong and not just have a default thing that hides your things to be wrong, right? So it's not a good place to use sentinel sometimes. But in any case, it's not too much of a thing. Okay, we'll use a JSON C list. So we convert it for you in edges. JSON C list of you append we, and also the other way around. Okay, and then is that enough? Yeah, I guess so, right? That's enough for the setup. We want to say color sub 0 is equal to is 0 indexed, yep. 0, and then everything just falls from it, right? So we have a deck, and this code is going to be, I don't remember what yesterday's code was. already. Is that the K one? Yeah, then probably use breadth first search. But I mean, what I was gonna say is that with breadth first search, most of my code looks pretty much the same. I mean, sometimes I use node instead of current or something like this, but yeah. And for this particular problem, you actually don't need breadth first search. You can also use depth first search or recursive based thing as well, because it is bicolorable. There are a lot of ways to do bicolorable things. It's just way a very cheap filter, if you will, right? So then now for we in what's it called, adjacency list of current, then if color sub v is none, then color sub v is equal to color sub current plus 1 mod 2. Don't even need the mod 2. I mean, you can mod 2 later. It doesn't really matter either way. And then yeah, put them in the thing. Oops, not good. And that's it. And it should connect everything, right? And then now we can just return colors, assuming that it doesn't have a none. Maybe we can add an assert. It should be fine. And then now we say yeah. So G1 for graph 1 is calculate edges 1. G2 calculate edges 2. And then now is for each of the first tree, right? Okay. So yeah, so answer, then for I in range of, oh man, we don't have a good n. Okay, fine. Just do this. Even though it's kind of weird, but maybe it's fine. Okay. So then now we have, oh, I guess it's the length of G1 because that's what we're returning. I guess that's more precise, right? So we have G1 of I, that's going to be the color, right? Oh, we didn't do a count. I guess we should do a count. I'm too lazy, so I guess I'll wait. F1 is equal to collections dot counter of G1. F2 is equal to collections dot counter of G2. So then now, so this is the color of the node I. So you, F1 of this yeah, I think the reason why I'm pausing a second is that okay, so what I want to write is something like this, right? This is just how many it looks confusing, but just how many graph or G1 nodes have the same color, right? That's it. That's all this is saying. And now what I want to write is like max of f2 dot values, right? Basically, we want to maximize the number of nodes on connecting to from edge 2, right? But I wonder if there's a case here. Meaning that, for example, if in f2 you have like 5 and 3 or something like that, like 5 reds and 3 greens or whatever color, then you want to connect to 5, right? But there is an edge case, right? That's what I'm trying to think, is that if you only have one node exactly, then you have to connect to that node, and that node will never be your other thing, right? Yeah, like you always have to have 0. So yeah, that's what I'm trying to say. Let me double check the constraints. Maybe that doesn't come up. Okay, so I'm wrong because there are at least 2 nodes on the constraints. Okay, so that I think this is fine. Because at least 2 nodes, then they're always 1 node of each color, right? Because that's just by definition, because they connected each other. You could, or I don't know if it's by definition, but it's trivially true anyway, right? So okay, so I think this is good. And in fact, we probably could, this does. You notice that this doesn't change as a result of the input, so you could probably take this outside, like Brody's used to say. I don't know. That's a bit. Why is my thing like I think the run button used to be like bigger. Like it's so hard to click. Like who did this? Who hurt them? Is this the focus mode? I don't get it. Like before it used to be like you made the buttons harder to run and for white space. Like the white space doesn't do anything. Anyway, alright. Like it's so hard to like click in between the run and the debug and the submit. Who wrote this? Who thought of this? Who thought this was a good idea? Yeah. Oh, colors and color. All right, looks okay. Let's give it a quick submit. And yeah, that's it. 1885 day streak. Pretty long. Yeah, I mean, there are a lot of times I would, and maybe I sometimes I explain this backwards, and I admit, and I'm kind of my apologies. You may wonder why I didn't talk about complexity first. I do go over complexity afterwards, but honestly, in a lot of my thought process, I go over complexity first. And the reason why I don't is because, like I said, I think this is that first search to color the graph, right? This colors the graph, and coloring the graph is assuming that, well, especially for a tree and two color, excuse me, it's going to be linear time, linear space, right? It's just two colorable stuff. You could see the code and see it's colorable. And it's very well known, so I knew this, and I knew that it's going to be linear time, and I knew that we just have to do like 2 times linear time. So I was like, I don't have to look at it, because if linear time is too slow, then it's not my fault anyway. Leetcode's fault, which is not impossible. But yeah, so that's why I didn't go over the complexity yet. But I hope that it is understood that in my mind, I think about complexity first before implementing. So yeah, so I go, okay, this is linear time, and hopefully I don't have to go over it. This is just a regular BFS, and this is a hard problem. So so we do 2 linear operations. This is also linear, right? But constant space, because it's always 2 color. And then yeah, and then this is also linear, right? We just do a loop to kind of go through it, and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to mental health. Go next. Hopefully, I'll see y'all later, and take care. Bye bye.